All right, the last thing we're going to talk about for this lesson is how to find area of any type of triangle. And that's what oblique triangle means. Rather than just focusing on a right triangle, focusing on any triangle that's given. So what happens is that I'm going to give you the formula ahead of time, and we're going to prove this one on the next slide where it is created. I just want you guys to keep in mind that this is the area is equal to, this is one formula to find it. This is another based on the angle given. So the area of a triangle is 1/2 the product of the lengths of the two sides that form the included angle. So in a way, this is a side angle side relationship given. I need to give you a side with the angle between the two given sides. Then we're going to use the oblique triangle formula, which is 1/2 BC sine of A. So notice the two sides are not the side length across from the given angle, are not the two side lengths across from the given angle, are not the two side lengths across from the given angle. All right, so we're going to prove that on the next page. Now, what happens if we're given the side-side-side relationship? One of your options, and I'm going to be honest, I don't use this formula. I kind of just make sure that if I'm given a side-side-side relationship, I'm going to find an angle, and then I'm going to use the oblique triangle one. But otherwise, what you can do is, since you're given the side lengths of A, B, and C, to find the area of the triangle, you find S. S is basically your three sides. So right here, it's your perimeter being divided by 2. There's your 1/2. Your S is taking care of this 1/2 part, taking the perimeter of that value. And that gets replaced in this formula. So it's S minus A, whatever the side length you want, S minus B, whatever side length you designate as B, times the side S minus C. And then you just take the square root of that. To me, I don't like this formula. Like I said, I'm going to find the oblique one. Where that oblique one comes from is the idea that we're given a triangle. It's non-right. So normally we know the formula for area of a triangle is equal to 1/2 base times the height. So in this case, in this triangle that I give you, your base is going to be the side length C, we'll say. So we're going to replace C. This is really equivalent to our base. And our height is going to be how tall is this triangle in relationship to our given side length here. There's my H. So if you think of this being a right triangle, in order for me to find H, if I'm giving you this angle here, I have an opposite, so I have a sine of B because I have an opposite over hypotenuse. So we're ignoring this fact because I'm giving you A and I'm giving you C in this case. We really don't know B based on the information provided to you. This is a side angle side relationship. So it's opposite over hypotenuse. So sine of B, the given angle, is equal to H over A. Well, we already have 1/2. And now we're going to replace H with the solving part here, where you get H is equal to A sine of B. And if you look back, this is kind of relationship to the ambiguous case, is that A is the side that's given that's not across from the angle, and sine of B is the given angle. So that builds right back into this whole formula that we found back here when looking for the height of B sine of A. So when you're calculating the height on these two questions, you're really calculating how tall the triangle is, which is why it's so important for this formula, because now I'm going to take this whole function, gets replaced in for H, and it turns out to be that area is equal to 1/2 C, replacing the H, A sine of B. So my given angle and the two sides that form the given angle. There's your formula now for any type of triangle. It doesn't have to be a right triangle. You don't have to calculate the height to find it and then drop your perpendicular. We don't have to worry about that now. We can just take 1/2 the two side lengths that make the angle B, plug it in and go. plug in C. So if this is 6, you're going to plug in 6 there. If that's 8, you're going to plug in 8. And then sine of the given angle of 30, 40, 50 degrees. If I give you 3 sides, like I said, you can find that angle, or you can use the Heron's formula. So for example, find the area of a triangle lot having 2 sides of length 90. So we know we have a 90 and 52. And the included angle is 102 degrees. I want to know how much space is this triangle lot going to take up. Well, I'm given a side. Those colors here. Giving you a side, angle, side relationship. So I'm looking at 1/2. Put the 2 sides that build the angle. So 1/2 90 times 52 times the sine. Notice it'll always be the sine, because it's always opposite of hypotenuse, of the given angle of 102. Making sure our calculators are in degree mode. So you take 45 times 52 times the sine of 102, and you get an area then of 2,288.87 meters squared. So that would be the area that the triangle lot has taken up. So instead of having to drop the perpendicular, we can plug this straight into our formula. Now, if I give you 3 sides, so we're given a triangle of, oh, my lord. Let's back up that one a little bit. We're going to undo the writing on that one. If I give you a triangle of 6, 8, and 10, I'm going to use the Heron's formula, which is the square root of s minus a, s minus b, or s minus c. So I'm going to go ahead and calculate s first, and s is equivalent to the perimeter divided by 2. So 6 plus 8 is 14, plus 10 is 24. 24 divided by 2 makes s is going to then equal to 12. So my formula then will be 12 times 12 minus 6 times 12 minus 8 times 12 minus 10. So you get 12 times 6 times 4 times 2. So 8, 48. 48 times 12 is equal to the square root of 576. And then the square root of that value is going to be 24. So that would mean that the area of this triangle would have 24 inches, feet, miles squared based on the given value that's provided to you. So like I said, I don't use Heron's formula. This is a pretty easy one to do. Otherwise, I'm going to find one of these angles, or possibly doing law of cosines, or dropping a right triangle and finding that calculation. So this is just more of a formula that we can use to give you another option. Like I said, I use this one a lot based on the oblique triangle. It's just that way I don't have to worry about finding the height and dropping all that perpendicular like we did here. Nice thing about it, it works for any triangle as long as you have 2 sides and an included angle. Where Heron's area, and I'm probably saying this wrong, Heron's area formula is if you give you 3 sides, just keep in mind that this s is the perimeter divided by 2. So you're adding that whole thing up, all of the side lengths, cutting it in half, and then you're plugging in s in there, just subtracting each side length from it. And that concludes lesson 7.4. So your sub will provide you the information in terms of which homework I'm going to assign. Pretty sure on this worksheet I'm not making you do them all. It's a lot of picking and choosing. So I want you to individualize your assignment. Please pay attention to details on it when I'm looking for directions. And feel free, if you got some questions, feel free to email me pictures, ask your sub. Just make sure you're advocating for yourself. I want you guys to be successful during this time where I'm absent. So you got a good sub that's going to help you through this. So please feel free. Ask me questions, ask her questions, ask anyone else in our department questions. We'll be back shortly. So I wish you guys the best and keep me informed. All right. Thank you.